Assalamualaikum warahmatullahi wabarakatuh and good day. We are from Group PEC 2218 F1 and F2. Today we are going to present about the pre-stress and precast technology. Pre-stress concrete.
What is prestressed? Prestressed concrete is the concrete that we stress out or pre-tension the road or tendon before pouring the concrete. This is used to reduce the deflection of the concrete to prevent from fail. Most of the structure used is bridge construction. Compared with reinforced concrete, pre-stressed concrete it offers better span, reduced structures, and lower material costs. Typically, they are seen in high-rise towers, residential facilities, base paved networks, bridge, dams, and nuclear power plants.
Next, for prestressed concrete, concept and interesting in prestressed concrete. And first one is the principle of the prestressed concrete is that before the load is applied, the compressive strength generated by high strength steel tendon in the concrete component during use. Second, low strength concrete cannot withstand the bursting pressure that is expected to arise at the big end. Third, attention must be transferred to concrete by bone operation. The concrete must be of high strength. Last, when high strength concrete is used, shrinkage crack can be made. As you can see from figure 1, load applied on the concrete member. Then for figure 2, the output force along the length of the beam contract the surface applied to the member.
Next, we will move on to the pre-stressed concrete, which is pre-tensioning and post-tensioning. For pre-tensioning, in a post-tension structure, the tendons are stressed, and each end is anchored to the concrete section after the concrete has been cast and has attained sufficient strength to safely withstand the pre-stressing force. For the post-tensioning, the pre-tensioning is accomplished by stressing wire of strength, called tendons, to predetermined amount by stretching them between two anchorage prior to placing the concrete. Next,
Okay.
Okay, you gotta break these nails.
Uh-huh.
Alright, bang on that. Pull this cone. And these two wedges,
Yeah.
they go along the outside of the cable like so. And,
Yeah. It just
and then that's it. And you take your spray paint. Well, I'll see these because and then spray paint at 12 inches, and that's his reference mark.
okay. And then you pull that out.
And then we put the machine on it, pull it, and then he references from here to the mark. And that gives him elongation.
Nice. How high do you go up to? 5,000?
I bring it to 5, a little over 5.
Yep.
Based on the previous videos, these are the summaries of the post-tension procedure. First of all, the removal of formwork. Next, remove the former and insert the wedges to the steel tendon of formwork. Mark the tendon by using the spray pen. Next, start stressing the tendon by using the stressing jet and measure the elongation of the tendon. Last but not least, cut the remaining tendon of the structure. Next is the reinforced concrete versus pre-stressed concrete. The difference between reinforced concrete and pre-stressed concrete is, for the reinforced concrete, minute cracks may be developed in the tension zone of concrete. while pre-stressed concrete, the technique of pre-stressing eliminates cracking of concrete. Next, for RC, it requires mild steel and concrete of lower grade, while for the pre-stress, it requires high tensile steel and concrete of higher grade. Besides that, reinforced concrete is costly tensioning equipment and entering device are not necessary, while for the pre-stressed concrete, it requires costly tensioning equipment and entering device. Last but not least, for RC, needs more quantity of concrete and steel, which result very heavy section, while for the pre-stressed concrete need less quantity of concrete and steel as compared to reinforced concrete, thus saving in weight. Precast concrete.
What is precast? The concrete which has been prepared for casting, cast and cured in a location which is not its final destination. Precast concrete components can be combined to form a complete structure such as wall panels, beams, columns, floor, staircase, pipes, and so on. Precast concrete is produced in a controlled environment and give the precast concrete the chance to be properly cured and carefully monitored by plant employee.
Next, we will move on to the cast in situ concrete vs precast concrete. For the cast in situ concrete, the concrete is poured on site, and for the precast concrete, it is cast at a different location and is then transported to the site. And second, for the cast in situ concrete, it is easily used for two-way structural system but relatively slower cure time. And for the precast concrete, it is faster curing as the process takes place under ideal and controlled conditions. For the third, it adapts to any building shape and post-tensioning. And for precast concrete, it is repeatability, easy to make copies of the same precast product and get the most value. And lastly, for the cast in situ concrete, it is no need to allot space requirement for concrete mix and necessary adds in. And for the precast concrete, its cost can be reduced due to the very few workers and rework.
Okay, next, why precast concrete construction contribute towards reducing carbon dioxide and global warming? For example, for 1 meter cube of concrete, for cast in situ asphalt concrete, the carbon emission are mostly contributed from cement and river, which represent on 60% of the emission. Adoption of more precast concrete can reduce carbon emission. This is because 1 meter cube cast in situ concrete produces 770 kg carbon dioxide, while precast only 692 kg, which is lower 10%. Secondly is precast concrete reduce waste generated at construction site as it is factory made. Third one is precast installation work quickly and efficiently, resulting in faster construction time and less on-site equipment, noise, and emission.